right, our next speaker is going to be Niklas Carlson, who is also from Linköping University, and he's going to be talking about StyleAdv, a usable privacy framework against facial recognition with adversarial image editing.
Thanks. So I'm here to present our work, StyleAdv. The current title is a usable privacy framework against facial recognition. Oh, sorry. Typical rookie mistake. I was telling my son, who's at the front row, let's try another one. That this is one of those times when I get nervous, and apparently I make mistakes when I'm nervous. So for PhD students in the room, also the senior people get nervous and make terrible mistakes. Anyway, so let's get going. So what I'm here to present is StyleAdv, so a useful privacy framework against facial recognition with adversarial image editing. The thing I can add here is that we're doing different type of editing here. So we're doing both semantic editing and residual editing, and I will get into this in a little bit. Now, most of the credit, or probably all of the credit for this, should go to my former PhD student, Minha. So he was the one that came up with the idea, did the work, etc. And I just enjoyed really interesting conversations with him. Now, one of the things that he wanted to do was, okay, we have images, maybe we want to upload them somewhere, and similar to previous work. But what he recognized was that a lot of people, they make edits to these images before they upload them. And then the question was, could we leverage that somehow? So, I mean, one way you can do an edit is, like my son maybe would do, just to replace my face with a Pokemon. And maybe that would be good enough. But this really reduces the utility of the image. So what he wanted was something where we make small edits to the image, but then keep the utility of it. So one of the things that he came up with was then StyleAdv. So a robust adversarial editing tool against facial recognition with a high image quality, with emphasis on high image quality. And then he had this idea, well, we can do semantic editing and sort of try different things where we do editing in different latent spaces with the help of these GANs. And turned out that we could do different ways of doing that, and we have it in the paper. The one that we're probably most proud of is this novel residual attack, so where we do residual editing. So that I would consider that as sort of a second big contribution. And then through these contributions, we offer then an integrated user-friendly platform for editing privacy. So we're providing a framework where you can upload an image, you can edit it, and put it on your social media, and then hopefully they don't retrain, and because then, as we've seen with other works, with retraining it becomes a little bit weaker. But as long as it doesn't get retrained, it's a quite efficient framework. In general, we demonstrate better performance over other adversarial methods. Okay, so what does StyleAdv do? Well, the basic idea is, again, we take images and we run them through StyleAdv. We do some form of editing, maybe sort of make a person smile a little bit more, or we do the residual editing where we sort of just do minimum impact on the image. But the idea is that an unauthorized facial recognition system should not recognize us on those images. Okay. So, and in general, we target an embedding based facial recognition systems rather than some prior work I've looked at classification based. And we're trying to maintain image authenticity. Our method is a little bit different than data poisoning, so we're trying to do a little bit of edits and then the freedom that edits give us, we're trying to leverage that to sort of evade these trained facial recognition systems. We do it again in two different ways. One is with the semantic editing, and the other one is with residual edits. With the semantic edits, we have a few different versions. One where we have non-guided, so we just, you can imagine that we saw before how we had an optimization function. So we also have an optimization function where we're trying to move the identity using some embeddings far away from the original identity while keeping sort of high image quality, and then we have some measures for what's good image quality. And then we have one where we do attribute-based editing. So now we take, say, I want to smile a little bit more in my image, and then I'm using that one. And then the third one is we're moving towards a target identity. And with the help of that, we can also then achieve some good results. Okay, so that's sort of the focus of the talk. Now, what is our threat model? Well, similar to previous work, we recognize that there's a lot of facial recognition systems out there. Let's use one of those models. So essentially download one or two or multiple. We're not looking at ensembles here, we're just looking at, we take one of them, but we try with different ones. And we can, in our framework, we can just pick one out of many. And then we put our optimizer on that using these different criteria depending on which type of editing we're doing. But then we're also recognizing that some systems we might actually be able to query once or twice. And similar to how the first paper had sort of a threshold, okay, when we've done good enough, we stop. So we have a stop criteria based on just a few queries. So when we beat it's good enough, then we might quit early if we can do queries against it. That's not always possible, and in those cases we just use a different model for the stopping criteria. Okay, so the solution approaches is either semantic editing, which is the framework that we see here, or where we have non-guided, attribute-based, and target-based. But in some sense, we're essentially just picking out different things in this chain to formulate our loss function, and then we optimize on that. For the residual attack, we're leveraging a few other things, and the optimization function ends up laying on a few other things. But again, it's just an optimization that do some tweaks to essentially what we're doing with the edits we're doing to the images, and then hopefully fooling the facial recognition system. And then again, we have a stopping criteria. Okay, so some example results. This is the original result, or sort of original images that we then tweak, that have different difficulties in terms of what we do with them. With a non-guided, we get really quick convergence, but not necessarily satisfactory results because we're losing a bit of control. With the attribute guidance, so say I want to smile a little bit more, I want to narrow the eyes a little bit, then we get a better balance and better protection, which was sort of our initial intuition. And then with this residual, we're sort of getting higher quality result with fairly quick convergence. And again, then it's more sort of the hidden noise. So some of you have worked with focus where you just put a lot of visible noise. And what we're doing instead, we're looking at the noise that we see in latent space, and we're playing around with adding noise in latent space rather than in the visual space. And that's essentially the idea behind the residual. And because of that, we get much more visually appealing results than we get with focus, for example. Okay, so then if we look at sort of or how good of an accuracy we now are, or how successful we are to fool these things. With the residual, we are able to fool in most cases on two different data sets. For those that are familiar, you can guess based on the acronyms. And for latent space, or the latent attacks, if you group them together, the accuracy is, or success rate is a little bit less, but still quite competitive. Okay. Now, if you compare with related work, so we have our original images at the top here, we We have focus, again, we add a lot of visible noise. It looks like I wouldn't put that on my website. Semantic adversarial, also, it's a lot of visible things. With the residual that we're quite happy with, it looks more like the original faces, and it looks, we don't see any sort of visual sort of bad things happening. We still have some adverse effects, but much less. And then we have our latent edits where we have to pick something to change, so the edits becomes a little bit more visible than the residual. But in general, if we look at them, I've claimed that sort of visually they look better. So if we take LPIPS, MSSM, and MSE, we can see how the residual attack have much lower values than if we take focus, semantic, adv, etc., and also better than on latent. If we look at sort of protection against verification distance, for several of these facial recognition systems, we're beating them. There are some cases where we have focus winning on what it's trained on, and semantic adv doing very well. But in general, we do quite well on, and especially then on the aesthetics, we get high quality images. In general, we're robust, provide robust protection, so essentially we see no significant reductions in the pairwise distance compared to no defense. So if I put out the no defense, which is to the far left in these ones, we can see that regardless of which defense is added, it doesn't do us much harm. What is doing us harm is when we actually let the attacker retrain on our data. So when we have an adaptive defense, so using model retraining on the modified images, then our success rate go down a fair bit. So we can see here towards the, I guess, out here, that it goes from, say, for the latent edits, for example, it's go from 99.7 to 35.9, but we're still beating the competition. So, for example, with focus and semantic adv, they're essentially doomed when you're doing retraining on them. And I guess others have seen similar results. Transferability, so if we train on one model and have another one as victim, we essentially do fairly well. So essentially here we're showing the average normalized pairwise distance compared to the threshold. So if we're doing a higher value than 1, we're sort of pushing the identity far enough, and we seem to do that even if we train with 1 and compete against another model. So in conclusion, we've developed StyleAdv for facial privacy protections through adversarial image editing. It's robust and user-friendly framework that you can try out yourself. That combines semantic editing and these residual attacks and facial recognition systems. It achieves realistic and high-quality images and provides successful attack rates. And then through our work, especially with the residual, which is the part we're maybe most happy with, we show that there's some advantage with using this residual information in the editing. And again, that's the bottom half of this image that you find in the paper. And in general, we outperform prior work. You can find the code and easy to run Colab examples on Minha's GitLab. And that concludes my admiration of Minha and his work.
We'll probably have time for one question. I think there's one back.
Thank you very much for your work. I find it very impressive to know that we can change a few pixels in an image in my photograph, and then I upload it, and the facial recognition system is broken. And I wonder about your thoughts on ethical implications of telling people, well, maybe actually not you, or maybe people reading the research saying, yes, of course, we can tweak a few pixels and it's gonna be fine. People go now and say, oh, you can wear a funky sweater, and like facial recognition in the streets is not going to work. People do similar research on like training generative AI model. You can fool the system, etc. But actually, in the real world, you don't really know like if the ML model is going to change it, when you're going to change the training system. So, what are the ethical implications of research like this?
So just to one thing before I answer. So we're not necessarily changing things in the image space. I mean, we see them in the image space, but we do the modification in latent space, and then we regenerate the images so get these more synthetic images that were mentioned before. But yeah, I think with all of these things, there's it's very tied to sort of deep fakes, and I can now sort of edit an image to look like somebody else, and then, but I think many of those things the tools are getting out there, and it's more the uses of them, and I don't think we're gonna be able to stop it. It's like the deepfakes are already out there. I wouldn't trust any movie or image, for that matter, that I see online, because the quality is getting so high, and maybe we are contributing to the bad side, probably to some extent. Our hope here is to actually not do that, but rather just providing anonymization tools rather than effective tools to target that somebody is somebody else. So we're hoping we're still on the good side.
All right. Thank you very much.